Scanning protocol. How does the prime scan work? What does this mean for the handling of the prime scan? What is our agenda? Basics, technical aspects, scan path, the scan catalogs, and a derived scan workflow for everyday tips and tricks. Objectives of this presentation. Important basics when using the prime scan. How and why perfect digital images, DI, can be created with the prime scan. How to scan most accurately and successfully, and which helpful tips and tricks will help us when scanning. Basics of the device. Handling the built-in internal heater. Why we should protect the scanning glass. What are the different camera sleeves and their hygienic measures. How we should handle the camera cable and calibration issues. The prime scan is designed as a completely closed system. This means that we also have an internal heater that protects the scanning glass from fogging and moisture ingress, but at the same time it is sealed so that we have no ingress of liquids during disinfection procedures. The sleeve completely covers this system and allows it to be used on the patient. In addition to the standard metal sleeve with fixed glass, there are other sleeves. The standard sleeve is a stainless steel case with a scratch-resistant sapphire crystal glass. Nevertheless, careful handling must be ensured to avoid scratches and therefore reduce the scanning result and scan quality. This means that we should avoid touching the tooth surfaces if possible and also avoid scratches otherwise. It can be prepared with a wipe disinfection, hot air sterilization, or high-level disinfection. The procedure for hot air sterilization is as follows. Number 1. First, a pre-cleaning is carried out. Number 2. Secondly, a removal of the sleeve from the scanner body. Number 3. Now guide the white protective sleeve onto the scanner head. The sleeve can be sterilized with hot air in a hot air sterilizer at 180 degrees Celsius for 30 minutes. Number 5. Then carefully put the sleeve back on before use and click it into place. First of all, pre-clean the sleeve. When handling the highly effective disinfectant, personal protective equipment must be used. The scanner sleeve has to be removed, inserted into the white protective sleeve, and then placed on the scanner holder. For highly effective disinfection, the disinfectant Sidex OPA can be used. Now the sleeve must be attached to the plug while the metal bracket is held to ensure that no particle contamination or liquids penetrate the inside of the sleeve. When properly attached, the stopper closes the sleeve. The high-level disinfection container is carefully filled to the mark and then inserted using the metal bracket with the sleeve. The sleeve must remain in the disinfectant for at least 12 minutes. In addition to the standard sleeve, there is also the disposable sleeve. The CEREC Prime Scan can also be used with them to ensure maximum infection control. This is intended for one-time use and has a smaller recording window. The edge of the scanning window is thicker and about twice as thick as the standard sleeve. The third available scanning sleeve is intended for intra-operative use. Sterile requirements have to be met here. Therefore, this sleeve is delivered in two parts. First, a metal sleeve and individual packed scanning glasses. The metal sleeve can be sterilized and assembled with the individually packed scanning glass. Since the camera is still a closed system, even without the sleeve, intraoperative use is therefore guaranteed. The camera is the most sensitive part of the prime scan. Therefore, the camera should always be placed correctly and carefully. The cable should not be twisted or severely bent. The best scanning results are always achieved directly after a calibration has been carried out. Therefore, regular calibration makes sense. Since it may be that the system was exposed to accidental shaking once a month, it is better once a week to calibrate the scanner. In complex cases, calibration should also be carried out directly before the scan. In any case, a calibration should be carried out after transport and vibrations, as they can occur during transport over steps, thresholds, and uneven surfaces. Be careful. The prime scan contains many moving parts, especially after storage in unheated or unair-conditioned rooms. Temperature differences above 30 degrees Celsius or 85 degrees Fahrenheit. For temperature differences above 15 degrees Celsius and 60 degrees Fahrenheit between the last calibration and operation. In general, if there are mistakes in the recording process, such as poor image quality or lack of 3D preview, perform a calibration. For best results, the CEREC scanner must warm up for 2 minutes before calibration. Technical aspects. The components of the camera. It has a large field of view, dynamic lens, active heating installed internally, smart pixel sensor, and intelligent processing of the image data already in the camera. It has a patented measuring system. This is a unique selling point of the prime scan. The measuring system has high frequency contrast analysis. As a result, each sharply imaged pixel is captured in its three-dimensional position. This leads to a much higher data density and significantly increased image sharpness. What's behind it? With prime scan, every registered pixel is also registered three-dimensionally. In contrast with other systems, 2 or even 4 registered pixels must be combined to calculate a spatial point, that is, a 3D pixel. Since every measured pixel is also a three-dimensional pixel, the prime scan achieves a significantly higher sharpness. Comparable products have to combine several measured pixels for each calculated three-dimensional point. This leads to a reduction in resolution and therefore in image sharpness. Dynamic depth scan. The imaging of the object on the smart pixel sensor is done, as with any camera, through an optical lens. This lens has a known focus point. In the prime scan, this lens is a dynamic lens and continuously changes this focus, therefore enabling the detection of different levels of sharpness of the object. With prime scan, 3D data is captured up to a depth of 20 millimeters, which also makes deep cavities scannable. The camera's large field of view captures everything within the field directly in 3 dimensions. This means that you can be sure that everything the camera has seen has also been captured in 3 dimensions. In other words, you get exactly what you need. In the combination of these two principles, each pixel contains 3D data. The dynamic lens captures the entire field of view, and over 100 million contrast values are captured per second. These are converted to 1 million 3D data points per second. The basis for prime scans' outstanding accuracy and precision is the extremely high density of 3D points. Scanning, slide 28. The large field of view and smart pixel sensor with their dynamic lens achieve faster and smoother scanning. The large field of view and smart pixel sensor with their dynamic lens achieve faster and smoother scanning. The internal intelligent processing already in the camera enables faster calculation with fewer interruptions. The significantly higher data quantity and data quality enables faster and more accurate stitching of the individual images. Already during the recording, everything that is captured as interfering data is automatically corrected in real time. Once the surfaces have been correctly captured, artifacts that are again in the scan field are automatically ignored. The benefits. Automatic correction means that no separate holding systems are needed. No assistance is urgently required, and no cutting tools need to be used to repeat scans in parts. We get exactly what we need. We have an even scan of all dental materials and allow capture even in difficult situations. With older camera systems, such as the Omnicam, optical triangulation made it necessary to tilt more, as we always get a shadow in the distal area. The more modern prime scan captures the entire field of view confocally. There is no shadowing, and therefore no tilting is necessary. All surface parts at an angle of 5 to 85 degrees to the prime scan are correctly captured. Similar to classic flash photography in a mirror, shiny surfaces prevent the capture of sharp images when viewed at a flat angle. The main arguments for prime scan: exact measurement and acquisition of 3D data from all dental surfaces, very low noise of the 3D data, and a significantly increased optical resolution. The definition of accuracy, correctness, and precision. Accuracy is defined as a combination of correctness and precision. Here, precision means achieving a result that is as consistent as possible without a large spread. In contrast, trueness means a position in the target area that is as correct as possible. Both together, that is, a small range of variation with the most correct detection of the correct value possible, means accuracy in the end. The prime scan enables the detection of all real physical surfaces. With comparative products, there is often a very high penetration of the physical surface and therefore an incorrect capture of the surfaces. The fact that every pixel is also captured in 3 dimensions and the high frequency contrast measurement gives us a high edge sharpness in 2 dimensions with high precision at the same time. The results are low noise 3D data. Confocal image acquisition. In the following, we explain the confocal focus adjustment, the stitching of the images, and explain that structured surfaces are scanned better than smooth surfaces. Due to the built-in dynamic lens, the confocal focus is adjusted differently. A contrast measurement is used to determine the area of focus in the captured image with a known plane of focus. This makes it possible to determine the 3-dimensional position of each individual pixel. Due to the absence of shadows in the distal area, Tilting is much less necessary with the prime scan. For a better understanding, there is a model setup. We have an object and a camera with a fixed focus at a known focus distance and depth of field. Here, only a small area of the object is in focus. By moving the entire lens back and forth, this area of focus over the object is changed and other parts are always in focus. Here, the principle of the dynamic lens with confocal focus adjustment is explained using 4 images as examples. In the first image, the front tooth is in focus. In the next one behind it, then the one behind it, and so on. Since both the distance between the camera and the object in focus is known, and it is possible to recognize in the image which area is in focus, the distance information, that is, the position in 3-dimensional space, can be concluded from this. The detection of the areas in focus in each individual image is done by contrast measurement. The joining of the individual images, the so-called stitching. By comparing 2 images, the overlapping areas are recognized, and these 2 images can therefore be correctly joined together in their spatial position. This expands the scan image by image and stitches the entire scan together. The more similar the overlapping areas are between 2 images, the more precisely they can be stitched together. This means that we should have as few changes as possible in the position of the space between 2 neighboring images. The position should not be changed in all 3 spatial axes at the same time. It is favorable to have plane parallel shifts or rotations and tilts in the same area without shifting the image section. The more structure that can be recognized on the surface, the more accurately several images can be stitched together. Clearly, structured surfaces such as cusps can be easily stitched together, while smoother surfaces can also be stitched together in multiple ways, which can lead to increased error. The technical aspects now result in concrete recommendations for scanning. Therefore, as few variations as possible should take place between several exposures during scanning. It should be noted that tilting is more difficult to calculate than shifting. The scan should be done in a smooth and even sequence without hectic movements. Smooth surfaces without a concrete structure are poorly captured and summed up. A concrete scan path can be derived from this. It should be taken into account that smooth, unstructured surfaces should be avoided first and should only be captured to complete the overall scan. This problem exists especially in the mandibular anterior region. Therefore, the overall scan should be started from the occlusal last molar tooth directly after lingual. The fixed and practiced scan path should always be scanning. Slide 45 and 46. Leandro Passos examined in his study the accuracy of cut-out scanning and over-scanning techniques. This technical procedure describes the accuracy of cut-out rescan and data exchange by over-scanning on cast areas using computer-aided design and computer-aided manufacturing software and 2 intraoral scanners. Methods. A customized cast was used as a reference standard and scanned using an ATOS triple scan digitizer. 2 iOS setups were used in 3 scanning groups, namely the control, cutout rescan, and data exchange by overscanning groups. 60 digital files, n equals 10 per group, were obtained and converted into the standard tessellation language format. A metrology program was used to evaluate the difference in accuracy between the control group and the other groups using Welch's unequal variances t-test. Conclusion. For trueness and precision of complete arch scans, the present technique provides statistical evidence that using data exchange by overscanning and a prime scan IOS result in higher accuracy scans compared to using cutout rescan and a prime scan IOS. The cutout rescan procedure provides scans with higher accuracy when using an Omnicam IOS. This technique is simple and saves time in workflows using a prime scan IOS. Scanning protocol. Leandro Passos et al. Also determined in his study impact of different scanning strategies on the accuracy of two current intraoral scanning systems in complete arch impressions, an in vitro study. The scanning strategy that obtains the most accurate results for two intraoral scanners, IOS, in complete arch digital impressions. Scan time was evaluated and correlated with scan strategies. The typical strategy scan is as follows. We start occlusally on the molar and then pivot lingually palatally to scan the inner surfaces of the entire jaw in one sweep. We continue the scan over the occlusal surfaces back to the initial occlusal eyepiece. From there, we tilt the scan window vestibularly again and scan in one sweep across to the canine without turning the camera. Then we start at the last molar again occlusally and then swing over to vestibular and scan over the canine as well. This ensures that there is no twisting of the entire jaw. This is shown here once again as a film. The description of the scan path. Always start at the same starting point, preferably the last molar from occlusal. It is best to position the camera without scanning and start directly when you have already positioned the camera. We only start when we have specifically scanned our starting point. Then we tilt lingual palatal to the last molar. Then the occlusal incisal further and don't rotate the camera. We continue to move parallel. Make sure that the further lingual surface is well captured. At the starting point of the last molar, tilt to vestibular buccal and continue horizontally to the canine. Continue over the front vestibular and stop at premolars. New entry, re-entry, at the opposite side of the last molar from occlusal. On the last molar, tilt to vestibular buccal. Continue over the front to the first side canine and then to the start side premolar of vestibular. You are ready. Summary of the 7 points to success. 1. Lingual. 2. Occlusal back. 3. After vestibular to 5. 4. Restart on counter 7. 5. Overlapping vestibular to 5 back. 6. Scan in the same place if possible. Little change between images. 7. Always do only one thing. Continue, move, or rotate or tilt. The scan catalogs. We have various scan catalogs available in the CEREC software, but which one do I need for what? First of all, we have the jaw with the prepared tooth. In this case, for tooth 1.6, the upper jaw. Secondly, we have the opposing jaw, in this case the lower jaw, and the buccal jaw. But which one do I need for something? I need the standard for the preparation jaw, for the opposing jaw, and for the bite on both sides. The biocopy is obligatory for the restoration mode biocopy. Also, for an overview of the initial situation, I need scan post for the fabrication of implants. I need the gingiva catalog for models with and without gingiva mask. Caution: constant areas must be present in folders so that they can be correlated. But which one do I need for something? I need the standard for the preparation jaw, for the opposing jaw, and for the bite on both sides. The biocopy is obligatory for the restoration mode biocopy. Also, for an overview of the initial situation, I need scan post for the fabrication of implants. I need the gingiva catalog for models with and without gingiva mask. Caution: constant areas must be present in folders so that they can be correlated. Always start with the jaw, otherwise the buccal bite cannot be registered. Like a plaster scan, we do not need a large area from mesial to distal, but only a small area involving the gum. We also do not need the scan in the area of the prepared tooth. A small section is enough to correlate the maxilla and mandible. This is always shown with the green tick. We use the biocopy scan catalog to copy and reconstruct existing restorations or teeth through to the original. This is also possible in parts of the tooth to be copied. To inspect and document the old situation and to check the restoration, such a biocopy scan can be of good use. Even if we have a basic scan of the patient, in case of tooth loss, we can copy this area as a biocopy so that we can then replace the tooth true to the original. Scan catalog gingiva is primarily there to really create and reconstruct the respective situations, especially with implant crowns. The scan catalog. Scan post. This is exclusive to the scan post registration. We need to scan enough to correlate the preparation jaw with it. Processing always takes place in the standard catalog.